Okay. I think everything is fine. So my mic is also on. I shared my screen. Today's class we will discuss method of variable separable. Method of method of variable separable. So in this, like we know very well that suppose two type of variables are there. Like one type of variables we need to transfer one side, and another type of variables terms we need to transfer one more side, and we will do the suitable calculation. So in this, note suppose there f of d into y equal to 0 is there. Suppose one differential equation is there, and the d operator is in the form of d by dx. That means the operator in terms of x means. And suppose if the roots are for the auxiliary equation, roots are a dot e. That means auxiliary equation. Suppose if the roots are minus m comma m is complementary function, that is c dot f y, solution will be c1 e to the power of minus mx plus c2 e to the power of mx. Okay, suppose if the roots are like this, two distinct and real roots minus m comma m, then its complementary solution will be y equal to c1 e to the power of minus mx plus c2 e to the power of mx. So remember this. Two distinct and real roots are there means you can write like this: c1 e to the power of minus mx plus c2 e to the power of mx. And next I will proceed to do one problem, then you will get clarity. Solve dou square z by dou x square minus 2 dou z by dou x plus dou z by dou y equal to 0. By using MSP, that means we'll write it as MVSP, that means method of variable separable. Okay. So next, this one. Answer we may consider it as dou square z by dou x square minus 2 dou z by dou x plus dou z by dou y. Okay, fine. We may consider it as it is as equation number 1. So next, to do this one, to proceed for this solution, we will consider the trial solution. Okay, considering trial solution. So here independent variables are x and y, and z is a dependent on x and y. So that is we need to consider like z functions in terms of x and y. We need to consider the trial solution. That is z equal to fx g of y. Okay. So suppose here x and t are there independent variables, and then we need to consider here f of x and g of t, a trial solution z equal to. Now in further steps, we will find out the solution f of x and g of y, and we will substitute here. Then we will get the required solution. And if you observe here clearly in the equation, we need to find dou z by dou x, dou z by dou y, dou square z by dou x square. Okay. So we will find out that and we will substitute in this. Okay. So here dou z by dou x means here we will get f dash of g. Again, dou square z by dou x square means f double dash of g, comma, dou z by dou y. That is dou z by dou y means you will get f g dash. F g dash. Okay. So here with respect to x we are doing means like g is a function in terms of y. That one you need to consider as a constant. That here you will get f dash. Internal function x if you do means you will get 1. Here again one more time if you do means f double dash of g here. Here dou z by dou y means f it is a function in terms of x. That one we need to consider as a constant. Writing outside. If you do g means you will get g dash. That internal y if you do also again it will become 1. Okay. So now all these terms we will substitute in 1. Okay. So by putting above terms in one as follows. Okay. Then we will get here dou square z by dou x square. In that place we will get here f double dash of g. Next here minus 2 dou z by dou x means f dash of g plus dou z by dou y means here f g dash equal to 0. So now here variable separable now we are doing, that means all f terms will uh, convert one side and all g terms will convert another side. Okay. Here from these two terms g is there, you can take g outside. So that means here f double dash minus 2 f dash of g equal to this one. I am transferring fg dash from right hand side, left hand side to right hand side. You will get here minus f g dash. Okay, then you will get here f. I am going to transfer from this side to this side, and g from this side to this side. So that means all f terms one side I am considering, all g terms one side I am transferring. Then you will get here f double dash of minus 2f dash f double dash minus 2 f dash by f equal to minus g dash by g equal to, I'm assuming some k. Okay, this ratio is there now. This ratio I am assuming equal to some k. So in the bracket I am writing say. Now from these two fractions are there now. So one fraction I will equate one time with k, and another fraction I will equate one time with k, and I will solve. That means we will get if you equate one time means you will get a solution for f of x, and if you equate another term, this term with this, means you will get a g of y solution. Then both we will substitute in z. Then you will get the required solution. F double dash minus 2 f dash by f equal to k. Okay, na? That is minus g dash by g equal to k. Now see here, minus g dash equal to kg, and minus g dash minus kg equal to 0. Then you will get here g dash plus kg equal to 0. It will reflect slowly, and we'll get auxiliary equation from this. That is the auxiliary equation. In place of g, you will get 1. That means k. In place of g dash, we will get m plus k equal to 0. And here m equal to minus k. So I will explain why here in place of g 1 is coming, why in place of g dash here m is coming. Okay. Suppose here g double dash is there, means you will get here m square. Okay. Here then g of y equal to, here we got the only single root. So that means here we'll get the here g of y equal to g of y equal to c1 u to the power of minus ky. So it is the g of y. Now I will explain that why here in place of g 1 is coming, in place of g dash is m is coming. Suppose here g double dash is there, means m square will come. Why means g dash plus kg equal to 0. That means g dash means dou g by dou y plus kg equal to 0. G take outside, dou by dou m plus k into g equal to 0. And here dou by dou y, it's the operator, na. So like actually it is in partial differentiation form. We will write an operator form. That means we will assume it as some d dash plus k g equal to 0. Okay. Generally for differentiation, we will apply capital D. Na. So that's why to show the variation, I am assuming here d dash for PD. Okay. So here we need to convert into an algebraic equation to get the roots. So that's why here d dash I will assume it as m. D dash I will assume it as m. Okay. M plus k into g equal to 0. Okay. It will reflect. So it will take some time. Yeah. Here you can see here m plus k is there. Okay. What are the in product for g, whatever it was in product, that one we will consider it as a auxiliary equation. Okay. So instead of doing this one, so directly I am writing. In future also, if anywhere it was there f or g, in that place we are going to write 1. If anywhere it was there f dash or g dash, in that place we are going to write m. If f double dash or g double dash is there, means in that place we are going to write m square. Okay. I explain that why you are writing like that here. Now here, so in place of f double dash, you can write m square minus 2. In place of f dash, you can write m. Reflect slowly. By f means 1 equal to k. It's reflecting slowly. That's why I need to wait. Then here from this equation, we will get m square minus 2m minus k equal to 0. So it is in algebraic equation in terms of m, that is a equal to 1 comma b equal to minus 2 comma c equal to minus k. For this directly you can't find the roots, that's why I'm going to use the formula m equal to minus b plus or minus square root of b square minus 4ac by 2a. Was reflecting, taking so much time to reflect. Why? Okay. Now it came. Finally it came. So m equal to minus b means here 2. 2 plus or minus square root of b square means here 4 minus 4. A means here 1. C means minus k by 2a. 2 into 1 m equal to 2 plus or minus square root of 4 plus 4k by 2. Can reflecting slowly. Yeah. Yeah, finally it is reflected. So 4 I will take outside, then you will get 2. So finally you will get here 1 plus r minus square root of 1 plus k. Okay. Then that means here m roots are 1 minus square root of 1 plus k comma plus square root of 1 plus k. Reflect, reflect. Is this reflect or not reflecting? Okay, then I will write once again. Okay, finally reflected. So here two distinct railroads we got here. So that is here f of x you are doing. That means f of x equal to, we'll get here solution. F of x equal to, here we already used the constant c1. Next we will get here c2 and c3. C2 e to the power of 1 minus square root of 1 plus k to x plus c3 e power of 1 plus square root of 1 plus k into x. Wait, it will reflect slowly. Reflect, reflect, reflect. Actually, it's a network issue. It was taking so much time to reflect. Finally came. First I could. Okay, finally it came. Then here solution, final solution z equal to f of x into g of y. Actual network issue it was happening like this. So not reflecting quickly. That's it. Z equal to f of x, g of y. We've already find that f of x and g of y solutions. So that is z equal to f of x and g of y. We consider a trial solution. So simply we have to substitute f of x and g of y. We need to write in product. That's only z na. So here c1 is e power my c1 equal to c1 into c1 e to the power of minus ky into c2 e to the power of 1 minus square root of 1 plus k into x plus c3 e power 1 plus square root of 1 plus k into x. So this is our required solution. That's it. This problem is over. It was not reflecting reflect. Finally it reflected after a long wait. This is our required solution. That's it. Next I will show to you for you people like two more problems you people try to do. Okay, because here due to network issue, even if I write in the board also, it was taking so much time to reflect. if people try to do this problem, example number here, note on this one, 18.2.